Hey everybody, thank you for tuning in. Today we're going to be talking about ASD roof loading combinations. So if you saw the video we were doing LRFD load combinations, we're looking at a very similar principle. Basically what we're talking about are design methodologies, and today's is ASD, which is allowable strength design, allowable stress design, which is different from LRFD just in the way they're designed. LRFD is definitely less common these days, especially within steel design. I would say they certainly can serve different purposes and can be integrated with each other, but LRFD is becoming more popular. These are the load combinations given by ASCE 716, as they were in the last video where we were using LRFD, but we're going to be doing an essentially almost the exact same problem, but we're going to be doing it with ASD loads. So you can see that we have 7 combinations here. Within LRFD, we have 5 different load combinations, so that's one difference. But one main similarity that's important is the difference in controlling factors. So when we're talking about LR or S or R, we're talking about LR, which is live roof, or S, which is snow load, or R, which is rain load. When you have 3 of these grouped together, as you're going to see in a couple of these different equations, it's important to remember that you're only looking at whichever one has the highest value. So if LR were to equal 100, S were to equal 120, and rain were to equal 30, and we'll say all of these are just PSF for the purposes of this, you would end up using the snow load in that because it is what's actually governing, it's the highest value. So let's look at a very basic problem. A roof has the following loads, and we're going to have to determine with the ASD method of design what the controlling load case is and what that controlling load will be. So let's just get right to it. So case number 1, it's just the dead load. We don't have any multiplicative factor, so it's just 70 PSF. Case 2, we have dead plus live. Now, one thing we brought up when we're talking about LRFD is that LR is not going to equal L. L is going to be referring to your live load, which is going to be, generally speaking, a floor live load, and that's different than a roof live load, and we can discuss why that's different in a different video, but one main difference is that if you're looking at something other than a roof load and you're talking about, say, column loading, there's a difference between the floor load and the roof load that is going to be applied to the building. So remember that those are different. So in this case, actually, we have no L value, no live loading value, so we actually just have 70 plus 0 is going to be 70 PSF. So the same there. Dead plus, 70 for the dead load, plus live roof or snow or rain. If we look up here, we don't have an R value, but we do have live roof and snow. So we have to look at these and see which bigger. It's going to be the snow load at 60 PSF. So 70 plus 60 is going to be 130 PSF. Now that looks more like our governing case because it's a higher value. Case 4, we're going to have 70 plus 0.75 times our live load, which is 0, plus 0.75 times what's our controlling factor here. It's going to be snow again, which was 60. If we plug this into our calculator, we are going to find that it is 70 plus 0.75 times 60 is 115 PSF. So that does not govern at this moment. 70 plus 0.6 times what? Now, I include a little arrow here to indicate that this wind we're talking about here is actually uplift. So what it's actually going to do is it's going to reduce instead of increase the value of the loading on the roof. So instead of plus 0.6 times 40, it's going to be plus 0.6 times negative 40, because the wind force is going to actually act against the gravity loading on the roof. And when you plug that into your calculator, you're going to find that you have 46 PSF. So once again, not controlling. We only have 2 cases left. Number 6, we have 70 plus 0.75 times 0 plus 0.75 times 0.6 times, it's going to be negative 40 plus 0.75, and our controlling factor is again going to be the snow load, which was 60. plug that all into your calculator, you are going to have 70 plus 0 plus 0.75 times 0.6 times negative 40 plus 0.75 times 60. You're going to get 97 PSF. And then our last one, we have 0.6 times 70 plus 0.6 times negative 40, which is going to give you 0.6 times 70 plus 0.6 times negative 40 is 18 PSF. So we can go back through here, look at the loads that we used, and we're going to see that we ended up with a governing load case of number 3 and a governing load of 130 pounds. So case number 3 controlled, and our controlling load was 130 pounds. So this was 130 pounds per square foot. So this was another relatively simple example. We're really just looking at roof loading here because we can talk conceptually about how beams are loaded and how columns are loaded a little differently and introduce point loads, but in terms of tributary area calculations where you just need to figure out how much weight is going onto a floor or a roof area, these types of problems are really helpful, and they get you a good grasp of different types of loading and how they are used for the ASD and LRFD load combinations. So I hope you guys found this helpful, and stay tuned for more similar videos. Thanks.